Okay, good morning to all. Myself, Dr. Rakesh Kumar, and today we will discuss the topic IoT Conceptual and Architectural Framework that comes under Internet of Things, that is IP 703B. Okay, now we are coming on the point that is IoT. Hello, that is IoT Conceptual Framework. Now you see that here in this there is example 1.1, that is physical object plus controller, sensor, and actuators plus internet is equal to IoT. So here example 1.1 showed single object umbrella communicating with the central server for acquiring data, and this equation describes the conceptual framework of IoT. Now in your syllabus, that is the conceptual framework and that is the architectural framework. Now we are discussing the conceptual framework. So in this conceptual framework we have taken the physical object, controller, sensor, actuators plus internet. That is equal to internet. Means Internet of Things is the combination of these. That is physical object, controller, sensor, actuators, and plus the internet. So here in this equation 1.1 conceptually describe the internet of umbrellas as consisting of an umbrella, a microcontroller, sensor, actuators, and internet for connectivity to web service and a mobile service provider. Right? This is the first conceptual framework. You need not to worry. You have to remember only this equation. This one. You remember only this equation. Okay. Rest you can do. Means that is the Internet of Things is equal to is the combination of these all of these. You can write this. Now, generally the Internet of Things consists of an internetwork of devices, physical objects, wherein a number of objects can gather the data at remote locations and communicate to units managing, acquiring, organizing, and analyzing the data in the processes and services. I will share this PDF on the group. Now, you have seen this is the combination of these physical objects plus controller, sensor, actuators plus internet, that is equal to Internet of Things. So here IoT normally that is a network internet work, that is the network of devices and physical object where the number of objects can gather the data at remote location. Okay, that is the by means of the sensors, but here you will see only the objects that can gather the data at remote locations and communicate to units managing, acquiring, organizing, and analyzing the data in the processes and the services. This was all about this equation, that is the single object, that is the umbrella communicating. Now, this is the journal conceptual framework. Now, we are coming on the equation that is the 1.2. Now, see, in the equation 1.2, here, this is another conceptual framework. Here, gather plus enrich plus stream, manage, acquire, organize, and analyze. That is equal to the Internet of Things with connectivity to data centers, enterprise, or cloud server. This conceptual framework is given by the Oracle. This is the main thing. When you will go in the question paper, you will go going with the question that is the conceptual framework. You will write this first. This is the generalized equation. This is the equation number 1.1, and then again you will go through that the architecture, the framework that is suggested by the Oracle. The Oracle suggested that the what is the IoT with the connectivity to data center, enterprise, or the cloud server. That is the gather data, enrich, stream. Okay, that is the flow of data. That is manage, acquire, organize, and analyze. This combination of these is equal to Internet of Things with the connectivity to data center and enterprise or the cloud server. Now here equation 1.2 is an IoT conceptual framework for enterprise processes and services based on suggested IoT architecture given by the Oracle. And these steps are the, now there are the levels. Now how you will categorize in the level? At the level first, data of services, data of devices, that is the things, using sensor or things gather the pre-data from the internet. That is the, this one, gathering the data, that comes under the level 1. A sensor connected to a gateway functions as a smart sensor. Smart sensor referred to a sensor with computing and communication capacity. That is the smart sensor. Later on, you will go with the sensor and the smart sensor. Also, smart sensor refers to the sensor with communicating, with computing and communication capacity. The data then enrich at level 2. For example, by transcoding at the gateway. Transcoding means coding or decoding before data transfer between two entities. That is the transcoding. And it means the data then enriches at the level 2. Level 2, that is the enrich here. This is in the level 2. That is by means of the gateways. A communication management subsystem sends or receives data stream at level 3. That is the streams. That is the management. This also this one. That is the stream. That how data flows. We gather the data, enrich the data by means of the gateway, and here the how the data that flows, that comes under the level 3. Now device management, identity management, and the access management subsystem receives the device's data at level 4. Means at level 4, that is the device management, identify management, and access management subsystem. This one, that how to manage, that comes the level 4. A data store database acquires the data at the level 5. That is the storing of data, acquiring data, that comes from level 5. And here, how the data routed from devices and things organize, analyzes at level 6. This one, organize and analyze, that is the level 6. So here in this equation, equation 1.2, as the conceptual framework suggested by the Oracle. So here we have the 6 levels. You have to write in the question paper in the answer that this has the 6 level. You will write this equation, and after that you will explain the levels. So first level, that is the gather the data. Second level, that is the enrich data, that is the by means of the, that is the gateways communication. Next is the stream data. Stream data, that comes the under level 3, that the communication management, that sends and receive data stream at level 3. And in the level 4, that comes the, this one, the receives the data, that is the acquire data. Manage data, that is the level 4. Acquire, that is the level 5. In the acquire, that is the data store database, as you till now you say that data is stored, that is the acquired data. And the organize and analyze, that comes under the level 6. So here in the framework suggested by the Oracle, there are the 6 levels. Okay, now it is clear to all. Next one, that is the again one more conceptual framework, that here you can see, that is the suggested by the IBM. First we done the Oracle, this one, and this was the first. All of you, please put your attendance in chat box. Now here, that is the, this one. First it was equation 1.1, second was 1.2 suggested by the Oracle, and third one, that is suggested by the IBM. So in IBM conceptual framework, that is the gather, consolidate, connect, collect, assemble, manage and analyze is equal to Internet of Things with the connectivity to cloud services. Now see the difference. Now see the difference. So here gather is here is the consolidate, and here there is the gather enrich stream. But here that is the gather, consolidate, connect, collect, assemble, manage and analyze is equal to Internet of Things with the connectivity to the cloud services. Now again that comes in the level. So here this figure, that is the equation 1.3, represents the complex conceptual framework for IoT using cloud platform based process services suggested by the IBM. This one. Now here, level 1 and level 2 consist of a sensor network together and consolidate the data. This one. This is the gather and consolidate that comes under the level 1 and level 2. First level, gather the data of the things devices using the sensor circuits. You can say the sensors. The sensor connect to the gateway. Data then consolidate at the second level. For example, transformation at the gateway at level 2. So this comes gather and consolidate in the level first and level 2. Here, the gateway at level 2 communicate the data stream between level 2 and level 3. The system uses a communication management subsystem at level 3. As information services consist of connect and collect, assemble, manage subsystem at level 3 and 4. The services rendered from level 4. So in level 3, that is the connect, here connect, collect, assemble, manage and analyze, and the real-time series analysis, data analytics, intelligent subsystem are also at level 4 and 5. A cloud infrastructure, a data store database acquires the data at the level 5. So here there are the 5 levels in the IBM conceptual framework. In the Oracle conceptual framework, there are the 6 levels. Okay. So here, that is the, we have done the 2 conceptual framework. First is the now Oracle. First was the journal, second is the Oracle, third is the IBM. In Oracle conceptual framework, there are the 6 levels, and the IBM conceptual framework, there are the 5 levels. Now, here, various conceptual framework of the IoT find a number of applications, including the ones in the end-to-end communication, that is the machine-to-machine communication networks, wearable devices, city lighting, security and surveillance, home automation. Smart systems use the things, that is the thing here. It takes the things as a node, which consists of smart devices, smart objects, and the smart services. Smart system use the user interface, that is the UIs, application programming interface, that is the API, identification data, sensor data, and communication port. Next, this was the diagrammatic representation. Here, as we have seen that the sensors, that is the gather gateway data, that is the consolidation, that is the level 2. This is the sensor level 1, level 2. Now here we have seen that in the IBM conceptual framework, there are the 5 levels, and the Oracle conceptual framework, there are the 6 levels. So here in the sensor 1, that comes under the level 1. So here this is the sensors. Here the smart sensor. Smart sensor include the application framework, IoT communication framework, and these are the sensors. We have discussed what is the smart sensor, smart sensor. So here the gather gateway data consolidation, that is the comes under level 2. This is the gateway, and here the connect, collect, assemble and manage, that comes under the level 3 and 4, and cloud services, that is the comes under the level 5. So in the IBM framework, there is the level 5 level, and the Oracle there are the 6 levels. So here now it comes to the IoT architectural view. So here we have seen in the equations that the 1.1 to 1.3, that is the multiple levels. Those levels are also known as tiers. That is the tier architectures. A model enables the conceptual framework. The reference model can be used to depict building blocks, suggestive interaction, and the integration. Here, till now, we have done from the equation 1.1 to equation 1.3. We have seen the conceptual framework equations, and we have seen the three conceptual framework, and we have divided those in the levels, and the levels they are known as the tiers. So a model a model enables the conceptualization of the framework, and the reference model can be used to depict the building block, suggestive interaction, and integration. Now you see, when you are going to make a project, when you are going to make a device or the project that based on the IoT, then you have to need this architecture, this framework. So here we are taking the architecture, that is the example of the Cisco presentation of a reference model comprise 7 levels. So here now I am taking the architecture of the Cisco representation, that is the this one. It has 7 levels. Now you see how the 7 level. So in this figure, that is the IoT reference model suggested by the Cisco that gives a conceptual framework for a general IoT system. Here, the Cisco gives the 7 layered reference model. The first, that is the level 1. Here, the physical devices and the controllers, the things of the IoT. It contains the sensors, machines, devices, intelligent edge node of different type. This comes under the level 1. And this is the physical devices and the controllers. And here in the level 2, that is the connectivity. How they will connect. That is the communication and the processing unit that comes under the level 2. And here in the level 3, that is the edge computing, data, element analysis, and the transformations. In the level 4, the data accumulation, storage of the data. Level 5, that is the data abstraction, aggregation, and access. And the level 6, that is the application, reporting, analysis, and the control. And the level 7, that is the collaboration process. It includes the involving people and business processes. So here in the Cisco, in this reference model, there are the 7 levels: level 1, level 2, level 3, level 4, level 5, level 6, and level 7. Level 1, that is the physical devices and the controllers. It includes, that is the things in the IoT, sensor, machine, devices, intelligent edge nodes for the different types. In the level 2, the connectivity. Connectivity includes the communication and the processing units. The level 3, that includes the edge computing, that is the data element analysis and the transformation. In the level 4, that is the data accumulation, storage. And the level 5, that is the data abstraction, that includes the aggregation and access. Level 6, that is the application, that is the includes the reporting, analysis, and the control. And the level 7, that is the collaboration and processes, that includes the involving people and the business processes. So this reference model was given by the Cisco. It includes the 7 levels. Now, this is the 7 level reference architecture are expected to coexist in the IoT domain. Now, this figure 1.5 shows the Oracle suggested IoT architecture. We have seen in the Oracle, there are the 6 layers. We have taken the conceptual framework of the Oracle. There were the 6 layers. This one, this was about the, this was of the IBM, and this is the Oracle. It includes the gather and this stream. Here, the level 1, level 2, level 3, and level 4. Organize and analyze, that is the is equal to Internet of Things. So now we are coming on this, that is architecture of Oracle. This one, this. We have seen in the Oracle the suggested architecture. New terms in the figure will be explained the subsequent. This one is the next lecture. So here, this is the IoT architecture by the Oracle. See here, this is the gather, enrich, stream, manage, acquire, organize, and analyze. organize and analyze. Wait a moment, please. Now, this was the IoT architecture by the Oracle. So here that is the gather, that is the same, that is the gather and the stream, manage, acquire, organize, and analyze. This is the smart sensor, that is the application framework, IoT communication framework, that is the again the sensors. And here this is the enrich, that is the gateway, that is the application framework, IoT communication and management proxy, IoT communication framework. So here in the stream that is the communication management, protocol handlers, message router, message cache, and here in the manage, that is the device identity management and the access management. And here you can see the device identity database, device access management, device identity management, and the device management. So here in the acquire, that is the data center management, that is the big data store, that are key value data store, and the database, that is the RDBMS, as you concerned with you, that you can use which database management system. And the organize and the analyze, that is the server management. This was the IoT architecture suggested by the Oracle, and that is based on the framework, six-layer framework, as we have discussed earlier in an equation, that is the 1.2. So here in this figure, that is the figure 1.5, we have seen the IoT architecture that is the suggested by the Oracle. And earlier we have discussed about the Cisco architecture. Cisco that is, gives the seven-layer architecture here, and the Oracle that gives the six-layer architecture here. Now, in this architecture, this one that is the this was the Oracle IoT architecture. In this IoT architecture has been following feature. Architecture serves a reference to applications of IoT in services and businesses and process. A set of sensors which is smart, capture data, perform necessary data elements analysis, and they transform as per device application framework and connect directly to a communication manager. The set of the sensor circuit is connected to a gateway processing separate data capturing, gathering, computing, and communication capabilities. The gateway receives the data in one form at one end and sends it to another form to the other end. And the communication management subsystem consists of the protocol handler, message, and the router and message cache. And the management subsystem has functionality for the device identify database, device identify management, and the access management. And the data routes from the gateway through the internal and data sources. And the data center organize and analyzes subsystem enables the services, business processes, and enterprise integrations. See, this is nothing to need not to worry. This is just explanation of this one. This one. You have see, you have the gather, that is the smart sensor, that is the application framework, IoT communication framework, and this is the sensor application framework, communication, that is the framework, this one. Okay. This was the about the architecture. So this one here, the one term that is the IEEE suggested the P2413. We will discuss later on this, but this is the standard provides the reference architecture for various IoT domains. So this was all about the. We will discuss on the just technologies behind the IoT. That is the hardware integrated development environment. That is the IDE. Okay, some protocols, communications, network backbone, softwares, and the machine learning algorithms. So these are the some technologies behind the IoT, that hardware that include the your board, that is the Arduino, Raspberry Pi, Intel Galileo, Intel Edison, as BeagleBone, and the IDE that depends upon that is the IDE is called just like the Arduino IDE. when you will take the Arduino board, then you have the Arduino ID, and that is different for the Raspberry Pi, different for the Intel Gladio and BeagleBone, and the protocols which you will use. We will discuss these protocols later on, and these are the some communications, that how the data will communicate with the other devices. That is the network backbone, the network architecture we will see, and these are the softwares, that which softwares we need. That is just like the Raspberry Pi especially. And next is the internet work in internet, that is the cloud platform. We will use the cloud platform also for the, that is the IBM Bluemix, AWS IoT, Cisco IoT. We will discuss them in the practical implementation in the machine learning algorithms. So these are the technologies that are behind the IoT. So there are technology, there is a server and technology also. So here there is the online platform device identification. So this was about the IoT architecture and the conceptual framework. We have discussed, that is the Cisco. We have discussed the IBM. We have discussed the Oracle. We have discussed the diagrammatic representation of the architecture also. So this was about the framework and architecture. Any questions regarding this? Okay, thank you.